Hello everyone and welcome to another Rivet tutorial. Today we are going to look at the OpenAI Assistance API and how to use it in Rivet, because I think it's not that easy for all the people, but there is some interesting stuff in here, like the automatic retrieval augmented generation with the files so that you can chat with your files, and a few other things as well. For example, the code interpreter, it can execute code for you, which I will also show you in a second why this might come in handy even if you do not plan to have any code or something like that created. Well, to get started, the easiest thing is that we are going to our OpenAI login, so the place where you also get the API keys, and we go to either Assistance and click Create here, or we can go to Playground, and now we can click here and press Create Assistant. It really doesn't matter. So let's just go here and let's do one. Let's do Assistance API demo as a name. And then as always, we can put some system prompt. The good thing is we only need to put it here once. We do not need to repeat it every time we are using, like with a normal chat node when we are using the chat node. So we just can save it one time. So let's maybe write just something silly to see that works. You always make funny robot sounds when you talk. And that's it. Of course, you should put something normal in here. So let's just choose GPT-4 Turbo Preview. And before we activate anything or do anything else, let me just save, and I will want to, because I want to show you why the code interpreter here is helpful, even if you are not sure that you need it. Because let's just ask, what is the current time? And let's run this. And we can see that the instructions were given, and now is the answer. Beep boop, I'm programmed not to have real-time capabilities, so I can't provide the current time. So this is because we have chosen GPT-4. GPT 3.5 usually tries to tell us something that's completely wrong. So that's at least okay, but we want to know the time. And we could, of course, add a custom function to do that, but we can also activate the code interpreter, save. Now let's just write. Let's see if this works, or if we need to restart the conversation. Let's just write try again. So we're waiting. And now we can see it's opening the code interpreter. And it's importing the date time. And now it actually gets the current time. And yeah, according to my internal clock, the current time is 12:58. I mean, it's 1 hour off, so it didn't really know which time zone. Yeah, it's also even reminding us of that. My internal clock may not match your local time zone. But we're already much clearer, and yeah, it can do much other things for you. It can create graphs for you. Let's just do that, create some example graph for me. It should be able to do that. And this is all things that only work if the code interpreter is on. So I highly suggest, if you're using the assistant, just always put it to on. There's not really a reason not to use it, because yeah, it just enhances the capabilities. So here we can see that it's now importing some Python library, matplotlib, for rendering rendering data, and it's running, and there we have some diagrams. So as you can see, it's pretty cool, huh? Okay. But let's not stay too long here, as we want to get to Rivet. So what we also want to activate, usually I guess, is Retrieval, because most people are interested in adding files. So we also need to mark this. Now we can add a file. And in this case, we are adding a study about self-rewarding language models. Let's add this. And let's ask it something about that. First we have to save, sorry. Okay, I'm not sure why this is taking so long. So that's a general thing. You also need to know this is all still in beta, and it's all sometimes buggy. You might see random errors when you try to send a message, or stuff like this happens. So let's just reload, because I'm pretty sure it already saved it or not. Let's redo this. And let's resave. Okay, that's not good. So I hope this is not going to take too long for the video. I will keep this running a bit, and while this is running, and hopefully it will be saving, we will take a look at the Rivet. Because I created a graph for you that makes everything simpler. I mean, there's still a bit in it, as you can see. But first of all, if you want to use the Assistance API, you need to activate this OpenAI plugin here. As it says, it's full OpenAI support, so fine-tuning, assistance, and more. And once you have that, then let's just focus, move that out. You can see this as a whole new point, a whole list here. And as you can see, this is really complex. There is a lot here. Because usually there is a lot also necessary to run this Assistance API. There's a lot of small steps. I mean, creating the assistant we are now doing via the UI. But then there's also creating a thread. So a thread in this case is the message history. The good thing about this is if we have a thread, then OpenAI keeps the history for us automatically. We do not need to handle that. And then but there's also other things we could, we also have to run the thread, and then the thread actually has multiple steps. And there's lots of things to it. But the good thing is the integration into Rivet is pretty cool in the sense that we don't need to do so much of that. So let's take a look at this graph. First of all, there's one input up here. This is our assistant ID. So we're going back, and now it's saved. The assistant ID can be found here. This is what we need to copy to be able to use it in Rivet. So basically we take this, we go here, and we replace it, Okay. Then we are already ready to run. So I will first show you, and then we can see how this works. So first thing is the user is the first one who has to do something here. So let's just say hello for the moment, or let's just say hello. Now we can see everything here is running. I will explain it in a second. And now we can see our answer, beep, bop, hello, how can I assist you today, we'll click. So we can see that the instructions are being kept, even though we don't add them again, and so on. So this is all fine, but of course not very surprising. So now let's ask something about the document. What is the... Let's ask for a summary of this study. So, because the document attached is a study about self-learning language models. So this might already take a while now, because it's doing lots of steps. It will using the code interpreter to open the file. It will read parts of the file, maybe multiple parts. But here we are. Beep, bop, click where the study titled Self-Learning Language Models explores the development of language models that can provide their own feedback during training using and so on and so on. So basically, this is it. That's all we need to be able to chat with our files. So it's really super simple. You can, if you need new files or different files, you can just go here and add them. One note, it's good if you name them properly, because the only information about the files the ChatGPT basically gets is this name, and it needs to know what file format it is, and it's also very helpful if it knows the title. So don't put unnamed or numbered documents in there. That might cause some issues because it doesn't really know what it is before it's looking inside. Okay, so now let's start a look how all this works. Basically, the graph is starting here. As we can see, first of all, we have some standard input for our user input. So the user input is the window where you can type in this chat message. So the standard is the first message we saw when we start the graph. What can I do for you today? This is the default value of this input. And then this is added to the user input. So basically we are seeing this pop up and we can enter our message. In the future runs, this will be different, but you will see that. Okay, now this message needs to be added to a thread, so that we have the history. So we are using the create thread message node. And for this one to work, we need a thread. And now we also have a default input for our thread ID, as we can see here. So we are creating a new thread, which returns a thread ID. And for the first time this graph here is running, we are using that thread ID. So if you watch those values here, you can already see we're on the third iteration now. And that thread ID here is not the same anymore as this one here. Because this one gets created every time, but it's not only used for the first run. So we can see here, if we go back, this thread ID here is stable. It's always the same value. That's how we connect all the messages in the context. Okay, and then this thread ID is necessary so that we know where the message we have typed in needs to be attached. So the content goes in here and the thread ID goes in here. And now we have one if here, which is just there so that this node here is not running before our message has been appended. So basically what we are doing here, we are just checking or waiting for a message ID to exist. We don't really care about the message ID, to be honest. But if it exists, we are getting the value of the thread ID and putting it through this output. So basically this is more like a timed gateway. So we are waiting with this. And once the message is there, we are putting it here. And now this is where everything happens. This is the most important new node in this for this assistance API. It's the run thread node. Let's take a look. First of all, we have a thread ID here. And yeah, that's a bit misleading. It's coming from an input. I mean, as I showed before, we are creating it here and then we are putting it in. Then we also have the assistant ID, which is also coming from an input. So let me correct that, which is up here. This is the one stable assistant we have selected so that we always talk with the same one. Okay, then I recommend not using this here because this is nice because you could get rid of the create thread and the create thread message. But the issue with this is this always creates a new thread ID for every single iteration of the chat. That means that you cannot have a consecutive history, not even on the short run. So if you only want to run this node once, this is perfect. You can just click this on and you don't need this and this and this. You can do that. But if you want to have a proper dialogue with multiple turns, then do not use that and then insert or either enter a thread ID here. Okay, other options is we could override the model that is configured in the assistant, but why should we? Same for the instructions. We don't need to add them, we already have them. Then again, there are the tools down here. They are auto-activated, so probably just keep them. And now the most interesting thing is down here. Because you might be wondering, I mean, everything ends here. So how do we even run this multiple times? As we can see, we have been running all this 2-3 times now. Basically, how this works is we can add an on-message creation subgraph. We can select one here. And on-message creation means when the LLM is actually giving us a message output. As you've seen before, there's multiple other outputs like that it's using the code interpreter and so on. But usually, I mean, there's not really a reason to show them. So mostly we care about the result. So what we can choose here is now another graph, which will be run once the message has been sent. And yeah, okay, this shows an error because I aborted the graph. So we cannot look at the values now. But let's look into this handle response subgraph. Here, when this is called, we actually have two inputs available. We have the input and the message. And you just have to create those graph input nodes and just put this in there. Call one input and call one message. And as we can see in the input one, we get a bit of a distilled part of the object where we can get the text and then the value. And then this is the actual message. So what we are doing here is we are extracting that. As we can see here, we're extracting from an array. We are going to the first level, then text and then value, and then we are getting the message. And we are sending that now we are calling again our chat loop, and we are putting this to the input now. And for the message input, we are getting a bit more information. As you can see here, it's a bit of a bigger object with more things. There's also the message in here again. So we could also only use this one. So what we need from here to make a consistent chat history is the thread ID. So we are extracting that here. And now this is being put back as an input to our chat loop. And now we are coming automatically back around here. And we are coming to, what I said at the beginning. We are no more using those default values here. As we can see here, what can I do for you today was the default value. But now we have the message answer from the LLM here. And for the thread, we also don't use the thread that is created here, but we are getting the one from the handle response here, this one, to keep it all together. And yeah, basically that is how it's work. Now we have the issue. If we run this, we will get the default value first. So we will get a new thread. That means at the moment we have a session-based history. Maybe that is what you want. But if you don't want that, we actually have a very simple second option here. We are just adding a text node, and now we are copying this, our thread ID that has been created, and put it in, and connect that instead. Now the first input already is our thread, which already has a history, and it will always be this one now. So we have kept it steady. So let's run it, and now let's ask it me a short summary of our previous conversation. Let's wait for the results. There we have it. Beep boop, in our previous conversation you uploaded 2 files and requested a very short summary of the study contained with one of them. I provided a brief summary mentioning the study's focus and so on. I mean, it's a bit interesting that it claims we uploaded 2 files. Maybe we had this issue that the one file did not really get uploaded, so maybe it sees something we don't. But besides that, as you can see, it clearly still knows everything we've been talking about. So now we have a permanent history. Let me disconnect that again for when I share this project later. But this is your way how you can get a stable thread ID. Now, there's only one more thing I want to show you. So let's abort the run. And that is how to work with functions. So if you don't know what functions are or don't need them, I mean, basically you can either stop watching the video or you can watch my function calling 101 video. But we will connect one now. So you will see. So we have a GPT function here, or now they're also called tools sometimes. And this one is called trigger toast event. And what does it do? It triggers a toast event in Rivet. If you don't know what a toast event is, you will see it in a second. And there is our description of a function in the format that OpenAI needs it. So basically that we expect it to send a field message with where a string is in, and this is supposed to be the text displayed in the toast notification. Pretty simple. And now, because we could have multiple functions, we are putting this to an array. This is not necessary with one function, but I just put it in, and we can see we have this function port here. So let's just connect it. And let's see how this fails, because we still need to do one more thing I want to show you. So let's just write, say, a toast message sending hello. So as I said, this will fail because we did not create a tool handler yet for the trigger toast message. So now this sounds complicated, but it's actually very simple. So the only thing we need is we need the name of this function and copy it. And now we go into the run thread node and we go into edit. When we scroll down, there's also this tool call handlers part here. And if you press add handler, we can just add the tool ID. And the tool ID is the name. So in this case, trigger toast event. And now, same as for the onMessage creation subgraph, we can just select the graph here. And I already put it here. We can take a look at it in a second. This is a trigger toast event graph. So we changed that. And let's try this again, but this time let's say, please like and subscribe. And let's see what happens. And as we can see here, we have a toast message. Please like and subscribe popping up. And our answer from as well. So that's the cool thing. We don't really need to care or handle functions. So let's take a look at what is in the subgraph, because it's so simple. As you can see here, the only thing we have is the same as for the handle response. You need to know there are special inputs. In this case, the important input, actually the only one you will probably ever need, is arguments. Those are the arguments to call the function. We don't need the function name or anything anymore because it already called the proper subgraph for the function. So we only need its arguments. In this case, we can see it's just this key message and the text. So what do? We extract the message, and then we are putting it into this raise event node. And if it's on the standard value toast, then we will see this toast message. But only one node if we are using the browser executor. If you use the node executor, you cannot see it. So that if you are experiencing that, then you maybe need to swap this. But yeah, basically that's how it works. I hope this was helpful. I tried to make it as simple as possible and cover the most important things. There are still some bugs in Rivet 1.77 I want to notify you about. For example, you can also configure functions at the agent level in the UI. But sadly, at the moment, Rivet forgets those functions. If you do not connect anything here, I think they are overwritten by nothing, and then you need to connect them from here. So that's a bit of an issue, which will hopefully get resolved in the future. But besides that, yeah, it works, and I think it's nice for testing it out and experimenting with it. So, as always, please like and subscribe, and see you in the next video. Bye bye.